Before I dive into demonstrating the types of problems that you're going to be working on my stat lab for your exams and your homework and your grade, I want to kind of ad lib one. So just run through a problem that I think is kind of interesting and just review some of the content that I just presented to you in the previous video. Easy for you to say. I don't know why I'm stuttering around like I don't know what I'm talking about. So if we go to StatCrunch website, you'll see there's a link that takes us to other data sets. Now these data sets aren't connected to your textbook, but these are data sets that people have uploaded. I always thought about doing one just for the heck of it. And there's some interesting things here. Major League players elected, I think that would be interesting. Car details, I think would be interesting. Some people, superheroes. Professor salaries would really be interesting to me. But there is one on college data, and I thought it was on page 2, but maybe yeah, here we go. Sample college data. So if you will click that, pretty cool data set, actually a pretty large data set. I think there's about 300 schools. Scrap that. There's 197 schools. But there's all kinds of cool stuff there that we could analyze about, quantitative, well, just a few categorical variables, but a lot of quantitative data here that would be appropriate for examining using this correlation and regression tool that I'm attempting to teach you. So when I look through here, one of the things that I think most interesting, and let me pump the brakes a little bit and tell you what I really find this interesting, is because both of my daughters are 18, 35 days difference in their ages. They're both adopted from China, so no craziness going on there. Uh, Meaning that how would I have two kids who are 35 days difference in ages? Otherwise, but they're both applying for college, and they're really smart, and they just excel academically. So they are applying at some pretty prestigious and expensive colleges. So one of the things that I kind of have on my radar is, first of all, the let's see, the tuition and fees and the retention rate. So, is there any relationship between the amount that you pay to go to college there and the percentage of students who are retained? Now, the very first thing you have to do is you have to decide, well, which is my X and which is my Y? Because you are predicting Y from X, X either needs to come at the same time as Y or it needs to come before Y. For example, what if I'm predicting someone's height from their weight? Well, that would be a reasonable question of predicting someone's weight from their height, right? Because both of those measurements can be taken at the same time. However, uh, people pay their tuition when they enter into college, and then the retention rate is determined later. So for that reason, I think tuition rate would definitely be my independent variable, my X, and I'm sorry, tuition and fees would be my independent variable, my explanatory variable, my predictor variable, and retention rate would be the Y or the dependent variable. So the very first thing I would want to look at is look at a picture. Let me find it. Should be scatter plot. And my X again is tuition and fees, and my Y is retention rate. Not going to worry about any of the rest of the stuff right now. So very, very, very quickly, back in the old days, I understand they had to perform these, create these things by hand. Today we can get a scatter plot of what, almost 200 people in a split second. Now, when you get something like this, what should you think? First of all, do we have a linear relationship or not? Secondly, is it positive, negative? Third is a strong, weak, or moderate. Let me repeat that. Do we have a linear relationship? If we do, is it positive or negative? Second, do we have a strong, weak, or moderate relationship? Well, as I draw a line through here, I try to visualize a line that best fits this data. I see a positive slope. Now, do I see a linear relationship? Sort of. Yeah, I think a linear model is reasonable for describing this data set. But again, there's a lot more, much of a prescriptive approach. But right now we're just learning, right? We're just in the initial stages. So we're just kind of eyeballing to see if we think a linear model. So right now it's say, yeah, probably. Positive or negative? Well, that's clearly positive because we have an increasing pattern to the right. Strong, weak, or moderate? Definitely not strong. There's a lot of variation over that around that line that I visualize. So I'm saying it's probably somewhere around a weak to moderate relationship. All right. Now let's dive into the weeds. Let's go to STAT, come down to regression, go to simple linear regression, and now we'll run the diagnostics. Tuition and fee is my X, so I'm predicting my Y, which are retention rates. Now, for the time being, all this, where and group by, don't worry about that stuff. The hypothesis testing and confidence interval, I'll teach you that in lesson 7. Graphs, there are some graphs here that take all the guesswork out of whether or not a linear model is appropriate. But I do want to say the predicted values. All right, because remember, one of the purposes of the regression model is to make predictions. Now, when I hit compute, I get a couple of things. First of all, I get my output. I'll explain all that to you in just a second. And the next thing I get is I get my scatter plot with the regression model drawn over it. So again, we made some pretty good guesses. Linear, yeah, sort of, not bad. Positive, absolutely. Relationship, I don't know, weak to moderate at best. Now, when I come back to this, let me make this a little larger so we can see it and I can highlight some things. First of all, my dependent variable, my Y, is retention rate. I always double check these and make sure you didn't get them reversed. If you get them reversed, you get the wrong answer and you miss the question. The next thing you're given is you're given your regression model. So when I see this as Y hat, which again is the predicted retention rate, can be found by taking 68.99 plus 0.00038 times the tuition and fees times our X. Sample size is 197. Our correlation coefficient is 0.41. R squared, I'll teach you this in a later video. Now, the analysis of variance table, I'll teach you this in lesson 7. All this standard error, alternative degrees of freedom, test statistic, p-values, I'll teach you all that in lesson 7. But for now, let's just look at the estimate. The estimate of the intercept is 68.99. Look familiar? And the estimate of the slope is 0.00038. Look familiar? Yeah, it's right up here. So you get your intercept and you get your slope in 2 different places. Now, it's going to be pretty wacky if those numbers are different. They're not going to be different. But if they are, give me a call because we got something going on really wacky. They're not going to be different, so don't sweat that one. Now, we have some predicted values, right? So if I was to put in each of these X values into my model. So for the very first one, I have 33,990. If I was to put 33,990 in here, multiply by 0.000376 and so on, and then add 68.989, so on, my predicted value, you can see that there's been, bring this down. This predicted value, see there's a new column that's been added because I clicked that predicted value box, is 81.9 or 81.795, so about 81.8. And notice there's a difference in what we observed the retention rate to be, 74, and what our model predicted the retention rate to be. Differences of about, what, 8 percentage points? These are percentages. 74% of the students retained, 67, 87%. Well, the difference, and again, don't sweat it too much right now, but this will be a focus in a future video. The difference on the Y that we observe in our data set and the Y that our model predicts has a name. It's called the residual. So the residual is the difference between the observed Y and the predicted Y. In notation, the residual is equal to Y minus Y hat. Because remember in the previous video, we introduced the variable Y hat as the predicted value for Y. Again, it all comes full circle to what is the primary reason of what's the primary goal of constructing a regression equation? It's twofold, right? To better explain the relationship between X and Y and to make predictions. I'm going to repeat that. To better explain the relationship between X and Y and to make predictions. So this component right here, namely that column, is the part making the prediction. Better explaining the relationship between retention rate and tuition and fees is explained by the slope and the intercept. So what would be the interpretation of the intercept? For a tuition and fee equal to 0, the predicted retention rate is 68.99. Yeah, that doesn't make sense because a tuition and fee of 0, the university wouldn't exist. And a lot of times your intercept doesn't make contextual sense. What is the interpretation of the slope? As tuition and fees increase $1, the predicted retention rate increases 0.00038, let's call it. All right, I could go on and on. I could teach on regression for the next probably 6 months and just never stop talking. And but that would be boring for you. So I'm going to, yeah, I'm going to end this. There's so many other things I could tell you, but we'll put those in a future video. All right, take care.